Hey students, in this video we're going to look at the construction method of jigs, and we're going to look at some of the components that you can purchase to use in jigs because they make the process of creating jigs a lot easier. In the next video we'll also look at some design practices. So first we'll look at the materials that are used to make jigs. So here we go. Jigs can be either built up or weldments or cast or purchased. And so a built-up jig means you're machining individual components, and you're going to take those individual components and you're going to bolt them together. And remember, in tool design we always pin something as well as bolting. So we use pins for location and the bolts act as clamps to hold it together, because we understand determinism, and in a jig we're trying to create precision holes, so determinism matters. So we're going to work hard to create good determinism. So a built-up jig is something that you can make in your own shop relatively easily. You can just use blocks of material. You're drilling holes and drilling holes for pins, threading things, and bolting it together. Now the downside of it is that they're not quite as rigid because they're bolted connections, and bolted connections aren't as good as some of the other methods as far as rigidity. But the good point is you can take these jigs and you can remake them into something else if you get finished using them, or you can take them apart so that they store in less space if you only use them occasionally. Now a weldment, you can start with the same built-up jig, and in fact it's a good idea to bolt it and pin those, or at least pin them, and then clamp them together and then do the welding. The downside of a weldment is you can't take it apart very easily, and during the welding process they will often warp somewhat. And so in a weldment you have to do the final machining of the precision features after the part is welded up, or you have to have a way to heat treat the part and to straighten it back out. Typically it's a better idea to build the jig body and then machine in the extra surfaces. You can imagine that if that's very big, then that machining process gets to be a lot more expensive to do, because now you're machining a big part rather than little individual parts. But you had to machine the little individual parts originally for them to go into the weldment. The third category is castings. So castings are a little more challenging. You typically would only use castings if you're going to make a number of these jigs, and you might want to keep that casting pattern around to be able to make more in the future. Some real advantages of castings are they're more rigid than any of the others. You have to machine them after you've cast them, of course, but because of any deflection that may happen in the cooling process, any warpage, it's really important to heat treat those castings to make sure that once you start machining, you're not going to spring any internal stresses loose and have them change shape while you're machining. That's a real problem. But one of the best things is if you make them out of materials like cast iron. Cast iron is a very good energy absorption material, and so it will absorb a lot of the vibrations that would happen in your machining process. It's heavy, but it's good for that. And so when you look at machine tools, most machine tools have a cast iron base for the machine tools. And it is completely for this purpose, to be able to absorb some of that energy so there's less vibration in your machine tool. The last is purchased or universal jigs. You can buy jig bodies, you can buy the U-shaped jigs, you can buy a tumble jig, and then you can put the part in there. The bad part of those is that you pay a whole lot more originally for them. They're fast because you just buy them, but you'll pay 5-10 times what it would cost you to make the jig normally, and then often you have to buy them in integral sizes, and so those sizes are often way bigger than you need, and so you end up having to use really long drill bits, or you end up having to use locators that are standing way off, and so you lose some rigidity. But that comes with the convenience of just being able to purchase the whole body and not having to worry about that portion. So how do you guide the tool? Well, to guide the tool, we use a thing called bushings. In the US we call them bushings. In the UK they call them bushes. And so you will see both of those terms around. In the US it's almost always bushing. Like on one of those previous drawings, it said bush. This is the bush. So anyway, the bushing is a guide. It is put into the jig body, and it is for the tool to pass through. So the reason that we use a bushing is twofold. One is it's made of a harder material than the jig, so it will last longer, and that way we don't have to machine the entire jig out of a really hard material that's going to take a lot of time to machine and burn up our tools. We can make it out of something that's relatively easy to use, like even aluminum or low carbon steel. But then we press these bushings into it, and because they are made of much harder material, then they will last a lot longer under the stresses of the cutting tool continually operating through the bushing. Also, that makes it so you can pull the bushing out and replace it later on if you do suffer wear. The second reason that we use them, I guess, is because they're replaceable. So we often, I guess I just said that. And so we can press them in there. We have to figure out what dimensions to use, but fortunately, because it's a purchased product, they will give us that information when we purchase it. One thing that we need to be really careful of is that if we're doing drilling processes, remember drilling processes produce these really long chips. And those chips are really sharp on the edges, so they make great cutting tools. And so what happens is if you drill the hole and there is no clearance between the end of the bushing and the part that you're drilling into, then the chip has to come out through the bushing. And if that happens, the chips will cause a lot of wear in the bushings. So a guideline is if you're using a material that makes little tiny chips, something like cast iron, where the chips come off as little flakes, then between the end of the bushing and the beginning of the part, you need at least half the diameter of the bushing. And that's the ID of the bushing, the part, the size of the drill bit that you're using. Now, if you have longer chips like steel and aluminum make, then you would want to have 1 to 1.5 times the diameter of spacing between the end of the bushing and the part. Now, do you always do this? No. Sometimes when you're drilling on the edge of a part, especially a circular part, you have to keep the drill from walking down the side of that part, and so the bushing would go all the way down and touch the part. And in fact, you will see in a minute, you can sometimes even shape the end of the bushing so it just fits snugly against the end of the part, so the drill is going to be in exactly the right place. But if you're doing that, know that the chips are going to come up through the bushing, and the bushing is going to wear much more quickly than if you were able to do it with a different process. So here is just a bunch of the different kinds of bushings that you can buy. Just easy bushings like this that are press fit bushings. Sometimes it's nice to have a head shape on the bushing so that you can pull them back out. This one also has this step on the side, so you can use a lock screw to lock it in place. And that means it's easier to pull that bushing out and put a new one in. You can have castable bushings, so if you want to cast your body, the jig body out of some material that's lower strength like aluminum and something that's much easier to cast, then you can put these hardened bushings into the casting, and they have all of these edges on the outside so they grip really well. Now, one problem with that is this is not a renewable bushing, and so when that bushing wears, you're going to have to replace the whole castable jig. We can do all kinds of other really cool things. If we have coolant passages in our jig, then they can spray through coolant directed bushings and get coolant right down there where we're drilling. We can also have oil grooves in them, so they're getting oil right down there to lubricate the end of the bushing, and so that's some pretty neat ways to do things. Yeah, just some more bushings. You can see that this one has some really jagged edges on the end. So if you do generate long chips, the bushing is actually going to work to break up those chips to make sure that they don't feed up into the bushing, but instead get cut. Oh, look, I'm in the way. There we go. Here is the end of the bushing, and you can see these jagged edges down here that will break up the chips. Okay. You do have to work on the fit of the bushing, so what size hole do you create in your jig to get the bushing to fit in there. If we have a longer bushing or a thin wall bushing or a bushing with a head on it that makes it so you can pull it out, you use less interference. You can also do tricky things like angle the end of a bushing, as I said, to keep the drill from walking down the side. And then also, if we have to put two bushings right together, we can either get thin wall bushings or we can get thick wall bushings, and we can grind one side so that they'll fit right against each other. There are all kinds of things that you can try. And when you do this, you'll go and you'll buy the bushing, and the bushing will tell you, the bushing manufacturer will tell you what size hole to drill, and they will often have that based on the material that you're into which you are putting the bushing. So if you're using an aluminum housing, they'll give you one number steel, another hardened steel, they'll give you a third number for what size that hole ought to be. So here is an example of that, where they will show you the tolerance that you need to have for your drill size. So which size bushing do you order? And then you will find when you get into this that there are myriad options of all kinds of different shapes of heads on them, whether you can pull them out easily or it's more difficult to pull them out. Myriad opportunities in the different types of bushings. Along with that, there are standardized values for GD&T sorts of things. So the concentricity of the bushings, and then things about the length and the head diameter and the head length. Now, one thing that this might, while you don't have to design the bushing, you just purchase the bushing, one thing that this might do is help to remind you that some of those items are pretty important, and so when you are designing your jig, you probably ought to think about having a concentricity call out on the hole, or true position call out, cylindricity, anyway, some different options for that hole. But that's a pretty important hole that you're putting the bushing into, and if the hole is not done well, then the bushing is going to be off at an angle, or will be squashed, or all kinds of things, and so then your bushing and your jig will not work very well. Final reminder here that some types of drills have to have bushings no matter what you're doing. So gun drills and BTA, remember, they are for drilling very deep, very straight holes. They have to have bushings to be able to start. The way that these drills work is the end of the drill is used to pilot where the drill is drilling, and because of that you have to start with a bushing to get it going in the right direction. Yeah, okay, so that is that. In the next video, we're going to look at some examples of jigs, and we're going to try to figure out from those examples what are some good processes and some good design decisions that were made on those drill jigs. And that will be really important because in class you're going to be designing drill jigs, so we need to have thought about this and seen some good examples of how people do it well. So I'll see you in the next video.